Hello everyone, this is Junaid here from Edureka and I welcome you all to this interesting session where we are going to see how we can predict house prices using machine learning. So without any further ado, let me quickly walk you through today's agenda. First off, we'll start this session by understanding what we are exactly going to do in our project, right? And then we are going to discuss what are the various types of tools and frameworks that we are going to use. And finally, we are going to get down to our hands-on demo. Alright, so before we begin, do consider subscribing to our YouTube channel and hit the bell icon to stay updated on trending technologies. And also, if you're looking forward for a deep learning training tutorial using TensorFlow, please check out the link given in the description box below. Alright then, so let us now get started by understanding what exactly are we going to do in our hands-on demo, right? So to understand this, let's see what exactly is our problem state. You see, over here, we are supposed to find or predict the price of a house given a various scenarios. The scenarios can be based on something like, median income of a person, the age of the house, the number of rooms that are available, and what exactly is the population in that particular area. Okay. And we are also going to do some feature engineering. And what exactly this feature engineering means is like, let's say we are given this latitude and longitudes, right? But this latitude and longitudes are just numbers. We cannot use this latitudes and longitudes to predict out which city or which area the house is located at. But we have multiple Python libraries using which we can generate or we can find out where exactly is this latitude and longitude. So we are going to basically use feature engineering to generate new data. And apart from that, we are going to use our actual data set and predict the various prices that can be given out for our particular model. Alright, so what are the prerequisites that you would be needing over here, right? Well, there is not much that you have to know, right? This is anyone who have a basic understanding of Python and who knows how to work around machine learning algorithms, how to use basic sklearn libraries, how to do feature extraction and feature engineering. They can easily cope up with this course. And if you're someone who has no idea about what we are talking about, the links for all of these courses will be provided in the description box below. Alright, now then. So now that we know what exactly we are going to do and what are the various prerequisites that you will be needing to perform or to work with this project, let's now understand what is the workflow that we are going to follow over here. So first off, we are going to collect our data, right? We can collect our data from various sources. We can say like Kaggle we can say sometimes Keras and sklearn also have their built-in libraries, or we can also scrape our website in order to get data. Okay. Apart from that, we have to pre-process our data. The raw data just cannot be used to our model. Okay. This is because, there can be many uncertainties. And apart from that, we have to normalize our data in order to get an optimized on an accurate result. Then moving ahead, we'll be doing some feature engineering in order to, get some new data, in order to, generate a new data, I would say, and in order to also to clean our data set. And then we are going to create a model. We are going to create model in 2 stages. In the stage 1, what we are going to do over here is, create a simple model using our sklearn framework. And then we'll see what is the accuracy that we are getting. All right. And then what we are going to do is we are going to try to use some hyperparameter tuning techniques such as random search CV or a grid search CV and apply this hyperparameter tuning on our model and see what result or what can we enhance in our application. And finally, what we are going to do over here is we are going to create a function which will take out any input from the end user, and then we can predict out the values, what number can be expected from a model. All right. So let's now get ahead and see what are the various frameworks that would be needed in your system in order to work with this. To start off, the framework that I'm going to use over here is Google Colab. If you're someone who's working locally on your system, you can use Jupyter Notebook or you can also use VS Code. I would prefer that you have, Anaconda so that you can create a virtual environment and install the various instances that you need. If you need a tutorial how to install Python and work around with Anaconda, you can just refer to any of our Edureka Python videos. All right. So in order to work with our data set, I'm going to use pandas. Okay. And apart from that, we have NumPy and sklearn. Basically, we use NumPy in order to work with any of the mathematical computation, basically arrays. And apart from that, we have sklearn framework using which we have many built-in libraries where we can create our own models. All right. So this is it about the tools and frameworks that we are going to work with today. All right. So let me now quickly move ahead to my code editor and show you how we can build our own model and see how we can validate and play with our data set. So as I mentioned earlier, the code editor that I'm going to use today is going to be Google Colab. All right, guys. So this is basically Google Colab. Google Colab, if you don't know, it is an IDE which is provided by Google, and you don't have to install any libraries here as everything is pre-installed, right? So let me now quickly get started. Fine. Let me give a title over here. If you want to give a title, you just have to click on text. We'll give this in a bold and let's say house price prediction. All right. So what is the first step that I'm supposed to do over here, right? So first thing that I need over here is going to be the data set, right? So how can I get the data set? As I mentioned earlier, either I can get down to Kaggle, and get the data set, or I can scrape the website, or the other or the most easiest manner is to, get the data set from the sklearn library. Okay. So the data set that I'm going to use over here today is fetch California buildings. So this would give me the various parameters, and the target parameter over here is going to be the prices. Fine. So let us now first import our libraries. Let me give a comment here. We'll divide the imports over here into three categories. First one would be the generic library, which I would be using throughout the application of our project. Apart from that, we have some of the libraries which are specific to a certain application here. So let me give you a generic libraries. Okay, so first off, we have something like import pandas. All right, so before that, let me just connect this to the server as PD. Then I have import matplotlib.pyplot as plt, and then we'll also import numpy as n, right? So these are the most generic libraries that you can execute over here. All right, so apart from this, now we have to import our data set, right? So let me give here as data set, and for this I'm going to use sklearn. From sklearn.dataset import fetch California housing. All right, and then this is it. And now let us now import our library. We'll give a comment over here, get the data set. Fine, we'll create an instance of this over here. Let me copy this and let's give the name here as data, and then fetch data, right? So let me paste it off. What this would return is, this would return me an object which would have multiple functions, and using those functions, I can create a data frame here. Let me quickly show you what I mean. So this thing gets downloaded over here, and now I want to know the description, right? So this will have many built-in functions. So we have first off data, then describe, feature names, and target. Let's go for describe, and let me type here as print. So now we'll get to know some information about our data set, right? So this data set over here has around 20,640 number of rows, and then apart from that, this has 8 features or attributes, and this is what each of these attributes represent. So we have medium income, average age, average room, bedrooms, population, that is the population of the block, then average occupancy, then latitude and longitude of the house that is present in. Okay, and you know what, I'm going to show you something over here where we are going to use the latitude and longitude value to get or generate a new values, which is also referred to as feature engineering. All right, so now that we know what exactly is present in our data, let us now create a data set, right? So to do that, all I need to do is create a data frame first. So we'll give the name here as df is equal to pd.dataframe. All right, so now we have to see what exactly is our data, right? We have to add this data to our data frame. So let's see what this gives us. Okay, so this gives me this particular row. Okay, so this is one record and this is one record. Now if you want to see the shape of this, now the shape over here would give me 20,640 is the number of records I have and 8 columns, right? So which is kind of similar to what we had here. So now we have to add this data to our data frame. Okay, and apart from that, we also need to add the features, right? So let me first show you what this would look like. So I have to add the data. So it will be data is equal to data.data, and then we'll have df.head. So as you can see here, we have 8 columns, and these are basically the rows, right? Each row. Now instead of the 0, 1, 2, 3, 4, I don't want this. Instead of this, I want the column names. So we also have an attribute over here as called as columns, and this should be data.feature names. And now once I execute this, you will see we have a data frame wherein we have every column and we have a name given to each and every of this column. Okay, if you're wondering how many rows we have, as I mentioned earlier, it's going to be 20,640 number of rows. So this is how we can collect our data, but we are not done yet, right? So this is just the beginning. Whatever data that we have imported over here, all of this is nothing but independent data, right? Independent data means this is not dependent on each other. So let me give a comment here, independent data. So this independent data is basically used for training our model. Now we also need to have a dependent data as well, right? So dependent data is basically referred to as output variable. Okay, so in order to get that, all I'm going to do here is df. I'll create a new column here. Let's say target. Okay, you can give this anything of your choice. You can give it as output variable or house price. Anything is up to you. We'll give it as target. And this target is basically going to be data.target. Okay. And if you're wondering what does this gives me back, if I run this here, so this is basically an array, right? And I'm just adding this array to my data frame here. And let me execute this. And now if you want to see how our data frame would look like, so let me give it as df.head. Now you'll see we have another column added, which is called as target. Okay, so let me just give this a clean look, delete this over here and execute this up. All right, so far what we have done, so far we have tried to import our data. All right, and then once we have imported our data, we have put that in the form of a data frame. Initially we got our independent variables or independent data, and then we got our dependent data. Okay, so let me give it as dependent. All right, so this is all there is about importing our data set. So moving on to the next stage, that is exploratory data analysis. So what exactly is this exploratory data analysis? See, before we move on to create a model, we have to understand our data, right? We have to understand whether there's any correlation between two features. What I mean is, if median house income and house age is correlated, then there is no use of using that in our model, right? While training a model, because when median house income is increasing, house age is also increasing at the same time. They both are similar, and in that way I can discard that particular feature, right? So let's now see what we can do here in our EDA. So one more thing that I would like to mention here, let me give it title here as EDA, or you can also say it as exploratory data analysis. Okay. In order to do our EDA simpler, right, we can use some of the built-in tools. Okay. And one of these tools is nothing but SweetWiz. So in order for you to use this SweetWiz tool, all you need to do is pip install SweetWiz. Okay, this will take some time for you to install. Totally depends upon your internet speed. Let me close this up. And now what we're going to do is we are going to determine how our data would look like in a graphical format. So in order for you to use this, all you need to do is import SweetWiz, import SweetWiz as SV. And then we'll create a variable here, let's say report. And this will be sv.analyze. And we'll give here as df. df is basically our data frame, right? And now I want to save this in a form of an HTML. So this is pretty simple. I'll just give it as report. And then we have something called as show HTML. And then we'll give an extension over here. Make sure you don't forget to give an extension of HTML, right? And now once I execute this, okay, so first off, let me import this thing here. Okay, and now we'll create a variable. This would be sv.analyze, and now we'll pass the df. And now similarly, all we need to do is show this particular part. Let me quickly remove this. And apart from this, now in order for this thing to work, we have to import tqdm. So let me execute this again. We'll obviously get an error. All right, so guys, if you're getting this error while running this SweetWiz, right, all you can do is, you can run this from the start, the entire notebook. So once you start executing this, right, what's going to happen is it's going to create a feature map, and this should be in the form of an HTML file, which you can see over here, report.html. Let me kind of zoom out now and let me show you how that would look like. Okay. And now let's try opening this HTML file, right? Okay, let me download this up. Let's say I have kept it here. Let me save this and open this HTML file. So as you can see here, we are provided here or presented here with some graphical values and what are the different stuff that we can do. So first off, you can see here medium income, this has a normal distribution. Age of a house doesn't have a normal distribution. And then average rooms, this is just a single value that is there. And apart from that, this is our target values, right? And now this also represents, what is the maximum value that you have, the average, median, mean, and everything that is present over here in each of the columns, right? All right, so this is how you can, perform exploratory data analysis on your system using a third-party framework like SweetWiz. All right, so this is how we can do EDA. And now moving on to the next stage, right? What we can do over here is we can pre-process our data, right? So now we have collected our data, we have looked into our data, which you can see over here, report.html. Some of the data we can remove. And then apart from that, what we can do here is the stage 3, wherein I'm going to do data pre-processing. And let me give this as a comment and hit enter. So first off, what I'm going to do now is let's see what exactly our data is, right? if I scroll up a bit, you will see here we have, various attributes like medium income, house age, average rooms, population, and finally we have latitude and longitude. See, latitude and longitude just by themselves is of no use for me. Okay. If there is any way, right, wherein I can use this latitude and longitude coordinates and somehow come up with an idea to find an exact location, like, city or a street, that would add up a couple more features. And let me tell you, more the number of features, better the accuracy that we are going to get. So for that, what I'm going to do is we have a library, something called as 𝐿. Using 𝐿, all we need to do is pass the coordinates, and once we pass the coordinates, we get the name of the city, streets, and various other parameters. And then we can perform, various filtering process. Let me quickly first show you what we are going to do here. This is basically nothing but feature engineering. And the library that we're going to use here is from 𝐿.geocoders import nomination. Okay. And now we are going to initialize this over here, library. So let's say geolocator, that is geographic locator. This would be equal to nomination, and then you can give here as user agent. And then I'm going to pass Geo API Express. Okay. Geo API. And this thing over here, user agent, right? Basically, this is an API. And every time I pass this latitude and longitude coordinate, it goes through the web, checks out which area it belongs to, and then passes out the result. Okay. And let me initiate this up. And now to give you a brief understanding what this thing does, let me call this a geolocator. Okay. And now let's pass some value, right? So we have reverse, and now I'm just going to pass some value. Okay. Let me say this latitude and longitude value. Okay. Let me just copy this and paste it over here. This takes input as a string. The first one is going to be the latitude and then the longitude. And let's execute this. All right, so I have done a small typo here. Let me quickly fix that up. All right, so the typo that I've done here is, this entire thing is considered as a string, right? So what I'll do over here is add plus, and then we'll obviously need a comma, and then a plus. Basically, I'm trying to concat two strings. So as you can see here, this gives me whichever area this thing is present in, right? And this is basically, if I give here 0, this would give me an array. And now this would give me what is the name of the area, ecological study area. Then, it gives me which way it is. And then finally city. This is going to be the pin code. California is the name of state, and this is the county name. Okay. So as you can see here, we are just going to pass this through all of the latitude and longitude and see, which area it belongs to. But hold on, before I move ahead, right, let's see, is it necessary? Because as I can see over here, all the values are the same. So let me go back to my report.html and let's see latitude and longitude. So here we can see a clear picture that there's a slight difference, right? That means I can consider latitude and longitude as one of my feature because not all the values here are the same. So let me come back here and let me give this as a comment. Fine. And now I'm going to create a function. Let's say def location. And what this thing takes in is a coordinate. And now we're going to pass here as latitude that we need. So it's going to be latitude, that is str, coordinate of 0. And then we have longitude as well. This will be str, coordinate of 1. So this is, we are going to pass this as an array. Okay. And now finally we'll create one variable, let's say location. This would be, we are going to just call this, right? We are going to call this, let me copy this over here. And now what I'm going to pass here is the name, that is latitude and longitudes. Okay. Separate this by a comma here. And then finally longitude. And if I tell you this, right, this can also be like a dictionary. Okay. This geolocator, if I want just the address, all I can do is pass this function here. Let's say .raw, and now this would give me a dictionary, and now I'll just give here as address. Now if I hit enter, you will see it gives me this. Now by any chance, if I don't put this address, right, you will see this basically a dictionary and it has all the values, address, country code, and everything else that is there. So let me give a function here, raw, which would convert this into a dictionary and then pass an address. This raw returns a dictionary. All right. And now what we are going to do is, sometimes, it's not necessary that, it gives me all the values, if they're not missing, right? So if the value is missing, what will happen is, we have to just replace that by nan values. In the later stage, when I try to, fix that, or when I try to, handle missing data, it would be easier for me. So let's say if the values are missing, replace by an empty string, or you can also set as nan. So how do I do this? I'll just pass a if condition here. If location, okay, that is location is this variable here, dot get, and let's say, there are various features that we need. If I re-execute this again, and if I just give here as raw and address, okay, you'll see here we have city, country code and all that. You see Berkeley and then country, we all know that, this is present in California. So I won't obviously be choosing all of these values, okay? The few of the prominent that one I'll be using is road, all right? And then we'll also see the neighborhood. If it's important, we'll also look into that. And apart from that, we'll also take a look into county, okay? So first off, we'll see that, if the value, that is if the location dot get. I hope you understand why we are using get. That's because, once I use raw, it's going to convert this into a dictionary, right? And now if in this dictionary, if the road parameter is null or none, that is if it's empty, then what I want is location of road, this is going to be none. Okay, so this is all right. So similarly, we are going to do this for other parameters like county. And then one more, we'll take it as neighborhood, but I guess neighborhood would be the same. So I'll just ignore the neighborhood parameter. Okay. So let it be this much for now. And now finally, we are going to update this, right? We are going to add this to our returning dictionary. So that will be LOC update, that is updated location. We'll give the name here as county. Similarly, change the name here, county dot append. All I'm going to do now here is call the location and then the county. Let me copy this and add it over here to the append. Okay, so this is one for the county and one again we'll do it for the road. Let me erase this and erase this as well. All right, so let me now show you what we are trying to do here exactly. Okay, so this function is there, right? This takes in the coordinates. Okay, and if you don't know what is this coordinates, this coordinates are basically our latitude and longitudes over here. These latitude and longitudes are present over here. Now this latitude and longitudes will be passed in the form of an array. That's why I'm going to use this as 𝐶OD0 and 𝐶OD1. Now in order for me to pass this latitude and longitude, I need to use this reverse function. And then when I use the raw function here, it converts it into a dictionary. Now what this dictionary contains? This dictionary contains various features like city, county, country code, and various other features. As almost all the features here would be the same, because obviously we know that it is a California. So Berkeley is there, then we have United States, which is the country name, and various other parameters. We're going to ignore that up, and we're going to take the one which has, a lot of variations. That is going to be road, and then the other one is going to be the county. So now in order for me to call this function, all I'm going to do is, just do a function call and create a dictionary here called as location update. As I've done this earlier, let me quickly just show you what this would look like. All right, so as you can see here, I have copied the code from earlier and I've added here. So initially I'm going to create this dictionary here which says a location update, and this dictionary would contain various parameters which are nothing but a list. So each of these lists basically contains, what is the county for this particular record 1, record 2, and various other records. Okay, and then I'm going to iterate this over the for loop. All right, and then every time I have this, I'm going to call my function and then finally add this to a pickle module. The reason why I'm going to use pickle module is because this would take me a long time. For me, it took almost 3 hours to get all of this data, and this also depends on your web speed. The reason is because first off, we have 20,000 rows, and apart from that, this is an API, so every time it has to make a request and get the data back. It is a quite tiresome task. So now if I don't want to execute this once again, I have already uploaded this in the pickle module, right? So let me quickly get that up. But before that, let me comment this and let me get the pickle module here. All right, so as you can see here, I've uploaded my pickle module here, and let me quickly load it and let's see how that would look like. So to load our pickle module, so to load the pickle module, all I need to do is first off import the pickle module here. So first off import pickle. Okay, let me execute this. Okay, and now we'll create a variable here. Let's say location update. We'll follow the same naming convention, and then I'll call this pickle. Then we'll load, that is load. And now instead of writing here separate instance for the file, all I'll do is open and then pass the name of our file, that is this. Let me copy the path. Now as this is going to be the binary file and I have to read it, if you remember, it's going to be RB, that is read binary. And now if I execute this up and let's see what this contains. So LOC updates. So as you can see, it has various parameters, right? This is basically a dictionary, right? This is basically the formation of this. If I just see here, right, dot keys, you'll get three parts: county, road, and neighborhood, similar to what we did over here. Although we will be dropping neighborhood as it's of no use, we just considering county and the road. Okay, and if I just put here as county, now you'll see we get all the values related to the county. Fine. So now in our next task, now that we have covered, or now that we have generated this data, now we are supposed to add this data back to our data frame. Okay, and before doing that, I would also like to delete this latitude and longitude data over here. So what I'll do, let's say we'll create a data frame here. So we have this load pickle, right? Let's say location, LOC, and now we'll create a data frame, pd.dataframe, and then we'll have location update. And now we'll see LOC info. So with info, right, I can get to know all the values which is there. So this is a function. Now we can understand how many values we have. Okay, so we have 20,640, which is the same number that is equal to the number of rows that we have earlier. And now let's see how many number of data we are missing. If you see the neighborhood, right, we are missing a lot of data. So this is one of the reasons why I have eliminated this. And then we have road. Road has few amount of missing data. And then similarly, I have it for the county. All right, so as you can see here, this county and the road, right, these are basically categorical data. All right, and I cannot just fill in, use a function fill NA and fill with some mean value or something. In order to get a better accuracy, what I'm going to do here is I'm going to create a model which would actually train on a certain set, and then wherever the data is missing, it would actually predict the appropriate values. So but before that, let me add this to my original data frame, right? And I'll also eliminate this neighborhood. So what we'll do here, add the new features to our data set, or I would say data frame, right? So for this, for I in location update dot keys, then we have df of I. df basically refers to data frame, and every time this would iterate over something like county, road, and neighborhood, and then we'll have LOC update I. So this would give me the entire row. Okay, and now in order to increase the randomness, I'll also have something like shuffle it up, right? So df is equal to df.sample. I want to sample the rows, so axis, this would be 0, and then we have another parameter here called as fref, and we'll give here as 1. Now let me see df.head. Let's see 10 parameters. So as you can see, our values or data has been jumbled up. So if I compare it to here, it's 0, 1, 2, 3, 4, and now here you can see it's totally jumbled up. And now we have a couple of missing data, as you can see, from neighborhood. I would remove that up. All right, and apart from that, we'll also have to remove latitude and longitude. The reason is because we have just created 2 new features. So let me quickly show you that. Drop latitude, longitude, and the neighborhood columns. Okay, so for this I have a built-in function df.drop, and I just need to pass my labels. Okay, and this labels over here is going to be latitude. Let's pass it off like latitude, and then longitude. So let me just copy it from here, just so that we don't miss out on typo. Latitude, longitude. I'll also remove the target just so that I can add it later in an order. So let me also remove the target here. And finally, I also have to remove the neighborhood parameter. So let me copy this and add it over here. Okay. And make sure you also pass an axis because I want to remove a column. So it's going to be 1. And finally, let's see df.head. All right. So as you can see here, we still have these parameters, right? That's because we have not added a parameter. Either you can update it like df is equal to so and so, or the other way around is in place, right? So as of now, let me keep it as df. And now if I execute it, you will see here we have removed these 4 parameters. Okay. And if I type this df.info, you'll see we have a couple of missing values over here, right? And now there are 2 ways to fill up these missing values. Guys, please listen to this carefully as it is pretty important. So what's going to happen over here is, either I can use minimum or maximum value that is repeating and replace them up. Or the second way around is, I can use linear regression or logistic regression. As is the classification task, I can basically use a classification algorithm, and the most simple one I can say as logistic regression. And then we can, whichever data is missing, that would be the test data. And the data that is not missing is going to be the training data. Okay, so let me write down here using classification algorithm to fill the missing categorical values. Okay, and now what we'll do is, okay, let me give this as a comment, copy this up. So first task over here is we need to define, or we need to find out which are the data that is missing, right? Which are the rows that have missing data. So first thing, I'm going to use county. First, we'll find the data for the county, or we can also use it for the road. And then, use any of these 2 or 3 parameters and to find out the missing data. So here, applying classification algorithm. So let me write that out. Applying classification algorithm, or let's say logistic regression, to find the missing value. Okay. And then we have, let's say, missing index. This would be an array. So what does this missing index have? Missing index basically will give me this index value, right? So I'll write here as for I in range df.shape, and this would return me number of rows and columns. I just need number of rows, that is 0. So what I'm going to do here is if df of road present in this index, in the ith index, is none. Okay. If this is the case, then add up the missing value. So I'll add that particular index value to my array. Okay. So missing index dot append I. All right. Okay. So now what we'll do is, there's a small thing that we missed out over here. You see, over here I tried removing the target, right? But we are also trying to shuffle our data. So this would be pretty tedious for us to, figure out which value belongs to where. Instead of removing the target, we'll consider not to remove the target. So let me remove this up, and we'll try running this from the start, right? So we might have to run this from here. As we are done with all of these, let me not rerun this again. Let me run this just to show you what we did. Here we try to create a function to generate the new features. Load the pickle, we have already done that. And then whatever values we have generated, right, we'll create that in a dictionary. And then we'll add this over here to this part. Now we are supposed to remove latitude and longitude and the neighborhood, right? So that's what I've done. The target variable is still here. And now if I see info, we have all the values present in the target. Only the new values are missing, right? So let us now get working on that. Okay. So now first thing, as we are trying to create a model, right, we have to define what are the independent and dependent features. So let me say independent features, parameters. So what are the independent parameters? Independent parameters over here with respect to county, it can be target, average occupancy, population, anything. So what I'm going to do is, let's create a variable here, missing road, as we are finding this for the road, right? So missing road, let me add this missing road values, missing road, and we'll give here as xtrain. Okay, and this should be np.array. And all I'm going to do here is, use a list comprehension. And as I've done this earlier, let me just quickly copy that from the previous one, just so that we can save up on time. So as you can see here, I have just imported the code from what I've done earlier. All right. And now you can see we have everything is similar. All I'm trying to do over here is a list comprehension. So I'll go through all the values, that is all the values in our data frame. Or if the index is not present in our missing index values, then just add up this medium income, average room, and average bedrooms of that particular row. Okay. And basically we are trying to create a numpy array here. And similarly, we are going to do this for the dependent parameter, and here the dependent parameter is going to be the road. Okay. And now coming down to the X test, this is something which we are going to predict. And if I execute this up, this will take quite some time, and it's done. Now, if I try to show you what this thing contains, so this would basically have 3 features, right? And these are going to be the independent features, and we are going to use these features to train our model. Now, as I mentioned earlier, we are going to use simple logistic regression. So for that, from sklearn.linear model, import, although I can use logistic regression, but I want to use a stochastic gradient descent. Okay. And now we'll try to initialize our model. So this will be model 1. And in order to initialize it, we'll just call this SGD, stochastic gradient descent classifier. Okay. Now to train a model. So in order to train a model, all we need to do is model.fit, right? So we'll have model1.fit. And over here, we are going to pass 2 values, that is missing train data. So this would be here, copy. And then even for the Y, the output variables. Okay. And finally, we have to do the predictions. So let me just copy this just so that we can stick on to the naming convention. Let me remove this from here. And let me put here as YPred, or it can also be test, totally up to you. And we'll have model1.predict the X values, right? The X values here is going to be the test values. Okay. And let's now execute this. So let me give you a recap of what is happening here. Meanwhile, the model is getting trained. So first off, we created this missing index array, and then we scouted through the entire data set of ours. All right. And wherever we have this missing value, that is wherever we have the row data missing, we just noted down that index over here. Okay. And then what we did, we had to create, obviously we had to create some data set for training our model, right? So for that, what we have done is, we try to use list comprehension here. That is for I ranging from the 0 to the nth minus 1, that is the nth position in our data frame. If I is present in our index, that is we already have a record, whichever index have a missing values, right? Then, if it is not missing, then add them to our training data set. And if it is missing, then add them to our predicting or the testing data set. So that's what we have done here. It looks like our model has been trained. And now if I show you what looks over here, missing row data, this would basically give me, what are the various streets I have. Let's now see what is the unique values. So unique, or I can just put it as np.unique and pass this over here. So as you can see, we have, these are the unique values that we have. And now what we'll do is we have to add this to our data frame, right? So that's pretty simple. So let me give a comment here first. Add the model back to the data frame. So for this, for n comma I in enumerate, the reason I'm using enumerate is because I can also get the index here, and we are going to iterate this using the missing data. That's missing index. So wherever we have the missing index, right? So df of road present at index I, this is equal to, we just have to fill this value. Okay, copy and let me paste it down over here. And now we'll just pass the nth index. And apart from this, the moment I execute this, all the values would be replaced back and we'll have no missing data. We'll also have to label encode, right? So let me also add that up. Okay, first let me execute this up. And now if I put df.info, you'll see there will be no values that are missing in our road data set. Okay. So we have 20,640 not null values. That means no values is missing. Now we have to label encode this. The reason is because our model cannot work on categorical features. So for label encoding, we have this built-in function from sklearn.preprocessing import label encoder. We initialize this label encoder. Let's say LE is equal to label encoder. And all we are going to do is, replace the value, that is df of road. We are going to replace this with le.fit transform, that is encoded value. So le.fit transform, this will be df of road. And let me execute this. And now if I show you what exactly df has, you can see df will have a categorical values. Okay, let me give it as head here. Now if you compare this earlier, so here the road and all were in the string format, right? Now you can see it's all digits. So this is what is label encoding. And let me add this back to this part here and give a comment. Okay, fine. So now we have done this for one particular function, right? So we have done this for road data. Similarly, we are going to do this for a county, but don't worry, we don't have to actually, rewrite the entire code. All I'm going to do is I'm going to copy these three blocks because everything remains the same. So let me copy this up and add it over here. Okay, and we'll just modify the data. Let me give a comment here first. Missing county data. You can put data or information. This thing would remain the same except for the road, it's going to be county. Okay, everything here remains the same as well. Instead of the road, we'll again give it as county here. Let me copy this up because all we are going to do is change the county value. We'll try to reinitialize this over here. This will take some time. And meanwhile, let's do this as well here. Now we are supposed to build a model. As we have tried to reinitialize this, it will not run the same. Let me give a comment here just so that we can avoid confusion. Predicting county information features. Okay, and again let's try to fix this up. We'll train our model. Meanwhile, our model is getting trained. We'll try to change these values here as well. So instead of road, it's going to be county, and similarly instead of road, it will be county here as well. Okay, fine. So finally we have tried to get all the data. Now let's try to use this model.info. So that will be df.info, sorry. And now let's see if there are any data that is missing. So as you can see here, we have filled up the road value as well as the county value here, and none of the values over here are missing. So now we can move ahead and try to build or create a model. Okay, so but before that, let me show you how our data looks now. So as you can see, everything has been converted into categorical features. So let's now move ahead and understand what model should we use over here. So let me give a comment here. All right, so this is a tricky thing. Okay, the most important part that is there, right? It's all about feature extraction, feature engineering. But after that, the second most toughest thing to do is to understand which model to use. Now we all know that this is a target variable, and target variable here is a continuous value, or I should say whole numbers, right? So the best way or the best model that I can fit over here is going to be a regression model. So that's what I'm going to do. I'm going to go ahead with the regression model. And the model that I'm going to use over here is going to be, random forest. So let's get started with that. But before that, let's try to, split our data. So first off, we have to get our X data here. So let's say we have Y, which is a target variable. So this would be df.iloc. I need all the rows, but just this column, right? So this is the target column. So this is -1, -2, and -3. So if I put here -3, and then put here values, and I'm gonna drop this -3. So if you want to see what this would look like, let me just show you. These are all the values of our target. Okay, as you can see here, 2.052 and the same thing over here. And we'll drop this, so it will be df.drop, and we are going to pass here labels, and make sure you pass the labels in an array, and we are going to give here as target. Okay, and this is for our dependent features. And similarly, we will do this for our independent values. So this will be X, df.iloc. Here we need all the values, right? So I need all the rows, all the columns, dot values. Perfect. Let's execute this. Okay, so access is not found. So let me quickly fix that up as well. All right, so now we have X and Y. And finally, we are going to add this to our train test split. So from sklearn.model selection, import train test split. And now all we need to do is call this train test split. If I just do this, we can get the documentation of our train test split here. If you scroll down, you will see what are the various documentation you have. And I'll just copy this from here because at the end of the day, we want to make our life easier. We come down to this part and add X and Y values. This here represents the split ratio. I would like to keep this in such a manner that 20% is for testing dataset and rest of it is for training. And let's execute this and we are done with this. So now what we'll do here is we are going to create a model. So the model that I said earlier that I'm going to use is random forest. So this would be from sklearn.ensemble import random forest for regression. So it will be a random forest regressor. Let's execute this. And now finally we'll create a model, that is model is equal to random forest regressor, and yes. And now let's execute this up and train our model, right? So model.train, so it's going to be model.fit, and you will pass your X train value and then finally Y train values, that is dependent and independent features. And let's execute this. This will take quite some time as we have around 20,000 values to deal with. Let's wait for a while. All right, so now as you can see, we have successfully trained our model. Now we have to obviously verify this, right? So verification of this is pretty important. So what we'll do is we'll do some model prediction. Okay, so first off, we'll take ypred. And what are this value that is going to predict? This is going to predict the test values. Okay, so it will be model.predict x test. So model has predicted these values. Now the important thing is, how will I know whether the model has predicted it right or not, right? So in order for us to know that, we can use R2 score. So model accuracy. Okay. So for this, I have from sklearn.metrics import R2 score. R2 score basically stands for R square score. And this is what we use for, finding the accuracy or how well our model is performing when it comes to our regression problem. So for this is pretty simple, R2 score, and you have to provide the actual value. So the actual value for this is going to be the Y test, right? So we'll give here Y test, and then we'll also provide here as ypred. And let's see what this gives us a score. So as you can see here, our model is performing really well. We are getting 99% accuracy. The value of this ranges from 0 to 1. 1 represents 100% and 0 represents 0%. So the closer your value is with respect to 1, your model is performing that well. Okay. So now you might be wondering, like, if you want to use this in a real-time scenario, how can you use it, right? So it's pretty simple. All you need to do is you need to pass your data in a specific format, and let me quickly show you how that can be done. So let me right here add our own data. Okay, so let's say we have this input variable, and this input variable will be an array, np.array, and what this contains is list of different features. Okay, so let's get back to our columns here, and let's randomly choose one. Okay, let's say medium income, house age, and we'll choose these features. Make sure whatever value you're giving is equal to the value that you have used for training. Obviously we have to reduce one, so because we won't be using the target value. We all know that this is a target value. Let me eliminate this. Okay, and let me give some commas, and let me execute this up. And if I put inp.shape, as you can see, we have 8 parameters. But now if I try to put this in my model, right? So let's say model.predict input, this won't work. It will say, we have to change the shape of this. So as you can see here, right? If you're trying to use multiple arrays, right, it's going to be a column matrix, so which you can see over here. But if you're using a single feature, it has to be in this particular format. So in order to overcome this, it's pretty simple. All we need to do is reshape this up. So let me quickly show you how we can do that. So inp, this would be equal to inp.reshape, and just pass the shape here, that is -1. So this is going to be 1 and then -1. And now if I do model.predict, okay, so it says the number of features must match, that is n features is 9, whereas it's 8. So let's see where we are going wrong. Let's first see what is inp here. Okay, so we have 1, 2, 3, 4, 5, 6, 7, 8. All right, so we have 8 features, right? But why is it saying 9 features? Alright guys, so as you can see here, we are getting this error, right? The reason why we are getting this error is because we have done a small mistake here. When we are trying to, remove this, we didn't update this over here, right? We didn't give in place is equal to true. So we'll fix that up. In place, this would be true. And now if I try to execute this, and let's see, our target variable is in there, okay? And let's try to execute this once again. Okay, looks like our model is done training. Let's try to reshape this and let's predict the value. Okay, so when we try to give this value, right, when you try to give this particular array, we are getting this value here. Let's now try to verify this up. Okay, yeah, so you can see we are getting a correct value, right? Let's say we are getting this. If I pass this data here, we are supposed to get 2.052, right? Or let's take something different. Let's take this. We are supposed to get 0.819 as my value or as my answer. Let me quickly fix that up. Let me add this and add values here with some commas. So as you can see, we have predicted almost the same value, okay? It's 0.92, whereas the actual value was 0.81. Okay, so there's a small difference, but it's all right. So as you can see, the value is similar, right? And with this, we can actually create a model. You can further improve this by, developing an HTML page and then adding a TK inter or something like that. So to create an interactable interface and put that on your cloud server, you can use Heroku or even AWS to deploy this. All right, guys. So what are the major takeaways of this project over here? Well, initially we saw how we can retrieve our data and then perform, feature engineering and also look into EDA, that is exploratory data analysis, and see which are the, the data set or which are the features that are of no use. And we tried to build two types of model. One, the model that was used in order to fill out the missing data, and the other model that we use in order to, predict the actual values. Now, the feature scope of this is that, you can implement this on a real-time website. You can take up or you can scrap the data from, popular Indian websites. You can actually build a real estate project and deploy it on a website. And who knows, you can start up your own business with this. All right, guys, with this, we come to the end of our session. I hope you enjoyed and learned something new. If you have any further queries, please do mention them in a comment box below. Until next time, goodbye and take care.
I hope you have enjoyed listening to this video. Please be kind enough to like it, and you can comment any of your doubts and queries, and we will reply them at the earliest. Do look out for more videos in our playlist and subscribe to Edureka channel to learn more. Happy learning!